Hi guys, in the last part of the video, we looked at calculating the rate constant k. We're now going to look at calculating something else from the rate equation, which may seem quite unrelated, but it's something you need to know how to do, and that is the overall order. All reactions have an overall order, and the overall order is just the sum of the individual orders of all of the reactants. So if we consider a rate equation given here in the form we're used to, where we have the concentrations of each of the reactants raised to their respective orders, then the overall order is just given to us by summing all of these together. So if we have order x, y, and z, the overall order is x plus y plus z. So putting in some numbers from the example we saw in our last video, we had reactant A, which was order 1, so we haven't actually shown it here. We had reactant B, which is order 2, so we did need to show it. And we have reactant C, which is order 0. So we could have left C out altogether, but we're just showing it here for completion because this final order could be anything. So the overall order for the reaction in this example is going to be the order of A, which is 1, the order of B, which is 2, and the order of C, which is 0, all added together. So 1 plus 2 plus 0 is 3, and the overall order for this equation is 3. So now, finally in this video, we're going to look at an example of calculating orders from experimental data, because this is something you will often have to do. How would you go about finding the orders of particular reagents? Let's think about this by considering the example given here. We have 3 different gases reacting, the first of which is nitrogen monoxide, the second is carbon monoxide, and then finally, a gas you should be very familiar with is oxygen. We're not going to worry about the products in this example, we're just going to think about how the reactants affect the rate and what their orders are. So we're given some data from 4 different experiments, and the trick to working out orders is comparing these different experiments, because in each one we're going to have different starting concentrations. So in experiment number 1, for example, we're going to have a sealed flask, which is shown in this diagram here, where the red lines show the seal, and the concentrations of all of the gases are 0.015 moles per decimeter cubed for the oxygen, which we'll colour code as blue.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the Snap Revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.